Okay, just a minute. Is it visible? Hello?
Yes, sir. Yes, sir.
Is it visible? I have shared, but I am not able to see. Just a minute.
Sir, earlier it was visible, now it is not.
Yes, just yeah, yeah. So
Now
welcome,
it,
sir, Dr. Pratapsinh Kakaso Desai. I heartily welcome you. Warm welcome, sir. Hello. Am I audible?
Thank you very much, sir. Thank you.
Thank you, sir. I would like to invite Dr. Bundele again to felicitate our guest of honor, Professor R.P. Yadav, Professor-HAG MNIT Jaipur, by presenting a memento.
Yes. Yes. Welcome, sir. RP Yadav,
Thank
sir.
you. Oh, thank
Warm
you. Thank you,
welcome to
Professor
you too.
Bundele.
Thank you, sir.
Thank you. Thank you. Poornima is
Thank you,
doing
sir.
well. Yeah. And
Thank you, sir.
well, yes, welcome to Dr. Pratap Singh also. Probably, yeah. I'm first time probably I'm meeting him, but welcome. Welcome, Dr. Pratap.
Yes, thank you. Thank you. Thank you, sir.
Thank you so much, sir. Now I would like to invite Dr. Mahesh M. Bundele, Director, Poornima College of Engineering, for his welcome address.
Yeah. Good morning, one and all. Honorable Chief Guest of this morning, Dr. Pratapsinh Desai. Guest of honor, Professor Dr. R.P. Yadav, former Vice Chancellor at Kota. Architect Rahul Singhi, Director Poornima Group, Dr. Garima Mathur, and other dignitaries and dear participants. It's indeed a great pleasure this morning that we are inaugurating this refresher course on artificial intelligence in Cooperative Noma, the that is 5G network, and it is sponsored by AICT and IST together. So I must thank first of all Dr. Pratap Singh for sponsoring this event in Poornima College of Engineering, and we have been organizing already. We are organized so many activities last year with the support of EICT and IST, and this time we could have you as a chief guest to inaugurate the event. So thank you, sir, for joining this inaugural program. I must also thank the Professor R.P. Yadav to be kind enough to inaugurate this particular event. Artificial intelligence, as you all know, everybody knows, anyone small kids knows these days the name of AI, because now AI is embedded in everything, even watch, mobile, or whatever kind of gadget, laptop, iPad, whatever you see around. So it's not now a new thing, but the new thing is that how we utilize the concept of AI, embed in different technologies, implement different solutions using AI as a tool, and then come up with the gadgets like we are using now. Already we have so many gadgets, so many facilities already created, but the looking to the futuristic applications of AI, it is very much important in particular your communication network. So this particular refresher course targets for that communication network, AI in communication network, particularly when it will be a 5G all around. very high speed network where high speed data flowing together at a time, at any point of time, at any place, you are able to see anything and you are able to transmit anything from anywhere to anywhere, so with very high speed. And that will be a scenario where you need to have a security will be a prime issue or challenge. In that case, AI can play a vital role, and that's what we are going for. Everybody is you can say afraid of the cyber security or the security in this domain. So it is very the networking, when you have a very good intelligent network, already we have intelligent networks, but most of the part is not so intelligent, or you can say it is not so safe. Even if we have blockchain technology today, we are not able to utilize it fully to the everywhere, every place. But this AI, when it will be embedded in each and every gadget, or you can say the component of computer networks all around the globe, or rather internet as a one particular layer or backbone of you can say the computer network. If it is secured by using the concepts of artificial intelligence tools and some most intelligence tools, if we are able to research and devise, that will be a very good outcome. Rather, I would request all the participants to think in this direction, that all of you are thinking or working on some or the other problem of computer network, and you are using some using AI tool or deep learning tool for this particular problem of security. Because security is very you can say other day I could see in the news that the direct transaction has taken place from one account to other account without any knowledge of anybody else. So this is very challenging job, and the security is very important part of this particular AI or other computer networks. So I'd request all the participants to be attentive throughout these 5 days of refresher course, and carry over some problems and the way of solving those problems at your end. Thank you very much.
Thank you, sir, for enlightening us. And now I would like to invite Architect Rahul Singhi, sir, Director Poornima Group, for few words.
Hello, everyone. Good morning. Respected Chief Guest, Dr. Pratap, Dr. R.P. Yadav, Dr. Bundele, Dr. Garima Mathur, Head of the Department Electronics and Communication, all our esteemed faculty members, students, and attendees who are currently watching us online. Thank you so much for joining us. I would just quickly brief you about Poornima and what is our history. So we started as a small engineering college in year 2000, and back then we had around 140 students in our campus in year 2000, and now we are a family of around 7,000 students and mostly 900 faculty and staff members. We also have sister concerns in Jodhpur with the name of Jeet College and Jeet Group. We ventured into healthcare in 2014. We have a hospital with the name of Medipulse Hospital Jodhpur. And we are soon coming up with a medical college in Jodhpur inside the Jeet premises or JIET premises. So we are now moving towards healthcare. But yes, our core domain is engineering because that has given birth to what we are today. So I would really want to, wholeheartedly welcome you and say thanks to you for coming online and joining us. And I would also like to thank all our coordinators, volunteers who have worked diligently and tremendously to make this wonderful conference for you all. I hope you take a lot of learnings and and have a memorable conference to attend. Thank you so much, and hope to see you soon in in campus whenever it is feasible. Thank you.
Thank you, sir, for your valuable words. And now, I would like to invite our guest of honor, Professor R.P. Yadav, Professor-HAG, MNIT Jaipur, to share his words of wisdom.
So, good morning. Good morning to all. Am I audible, ma'am?
Yes, sir, you are
yes,
audible.
Oh, good morning to all. Chief guest of this faculty development program on artificial intelligence in cooperative Noma network, Dr. Pratapsinh, Dr. Mahesh Bundele, Mr. Rahul Singhi, a second generation, you can say, entrepreneur after his father. Yeah, and coordinator of the program, Dr. Garima Mathur, and I am not getting the name. I mean, who welcomed all of us. Maybe yes, madam. My
Dr. Anila
Dr.
Digla.
Anila, yes, my greetings to you also, and all participants who are joining online. It's a really great. Poornima Institute is taking a lot of initiative, as I have seen over the last many years, that they are conducting a lot of such programs, educating, training faculty all across the country, in fact. And it's a really something very heartening to me also that they are taking all, you can say, interest in making people aware, student, educating them about the latest technological changes, in fact. And this particular program also, I think, is in series of that. And all of us know, in fact, as told by Dr. Bundele also, artificial intelligence, deep learning, machine learning, and automation. Nowadays, I think you name something and things are really changing very fast. And so, I mean, we are living in a time where you can say wireless communication systems have become almost indispensable. And the issue is, in fact, all automations, all technological, you can say, upgradations. Now, communication is must. And starting from, you can say, our mobile communication, we have first generation, you can say, analog systems in US when it started first, 1G communication, you can call it near about 1974, 75. And since then, we you can say evolved to 2G. That is, you can call as somewhat digital systems based on TDMA. And then came the third generation, because after voice transmission, there was a need for data, you can say, requirement. And a lot of people wanted to, you can say, transfer data. And this all, you can say, online, our systems that you can say mobile internet, in fact, that is revolutionizing, you can say, all our services, in fact. And uh, after, you can say, 3G, because 3G had some issues, technological issues, let's understand, came the 4G, that's LTE, advanced LTE, where we went for OFDMA. OFDMA also had certain advantage, but still it has some issues about spectral efficiency, about some, a lot of, you can say, I mean, you can say latency, I mean, massive device connectivity that we are talking right now. So 4G, you can say also, you can say people, or when you connect so many devices, this is, you can say, not sufficient. And that's how you can say people are now talking about 5G, which is likely to revolutionize a lot of things. I think we will talk more about it when I have my talk. But it is sufficient to say that this particular transformation in technology, how it is impacting our, you can say, life also, that we can see. And then we have to make a use of it, take advantage of this technology to make our presence felt. And for that purpose, we need to educate our, faculty members, our students, to understand the different aspects of the technological, you can say, which they can make use of, and they can have a really, you can say, a presence across the, not only our state, but across the country also, and across the world also. So my sincere, you can say, greetings or sincere compliments to Professor Mahesh Bundele, Dr. Garima Mathur, Dr. Anila, and Rahul, along with Dr. Pratapsinh for giving this opportunity to Poornima, our our engineering college, and thanks to all the participants who have joined us on online. And they will, I hope they will take advantage, or they will learn a lot of things which will be useful for incoming, you can say, their career. Or thank you.
Thank you, sir. Your encouragement always keeps us going. It's my great honor now to introduce our chief guest, Dr. Pratapsinh Kakaso Desai, President ISTE New Delhi. He has completed his PhD from Shivaji University, Kolhapur. He has completed master's degree in mechanical engineering and masters of business administration. He has prominent background of social reforms, patriotism, and education. He is working on design and development of femur bone prosthesis research. He delivered keynote addresses in India and abroad in conferences, especially his deliberation on opulent Indian education, and his history is highly revered. He has numerous national and international research papers to his credit. He has actively participated as member of All India Federation of Polytechnic Teachers Association. During his tenure in various organizations, he was instrumental in advocating the issue of granting pay band 4 to all engineering and polytechnic colleges. He is a member of various committees and task teams constituted by Government of Maharashtra. He attended and participated as member of Indian delegation on various international meets. He is youngest ever president of the prestigious organization ISTE New Delhi. I welcome you, sir. It's my immense pleasure to invite our chief guest, Dr. Pratapsinh Kakaso Desai, President ISTE New Delhi, to grace the occasion with his kind words.
Thank you, Dr. Anila Dhingra, for a very kind introduction of mine. Chief guest of honor of today's inaugural function of 1 week FDP being organized by Poornima Group of institutions. Professor R.P. Yadav, sir, rightly pointed out that entrepreneur of a second generation who is managing the show exceptionally well. That is what I heard. I have never met him, but I heard. So, architect Rahul Singhi, director of this institution, Professor Dr. Mahesh Bundele, the person instrumental behind getting this program, taking this program to Poornima institution, and being continuously in touch with me and making me myself available today for this program, Dr. Garima Mathur, my colleagues in the faculty, ladies and gentlemen. At the inaugural address, Professor Mahesh Bundele said that he thanked the IST and AICTE for giving this program, giving this opportunity to this institution. So let me tell you one thing very clearly. Whenever we scrutinize the proposals, it's a team of IST and AICTE. Whenever we scrutinize the proposals, we look into the two things. Number one, the reputation of the institution, its capacity, its capability to do justice with the program. So when it came to Poornima institution, I still remember Professor Punia had an important word. He said, this is one of the institutions doing good. Doing good. So I never had been to this institution in the past. Yes, many institutions in Jaipur I visited, but not this. But yes, you have earned credibility. You have earned reputation. And that is why your name is shortlisted. That was the first parameter. Your reputation. And that's all credit goes to you. Number two, the topic. So relevant, so important, very apt and very appropriate at this point of time. Because Professor Yadav was talking about it. I'm not expert in this. I'm a mechanical engineer. and that too outdated mechanical, because when being in the teaching profession for almost more than 30 years, and that too not a working this thing, no, very little touch with the industry. Therefore, I'm saying that I'm bookish engineer, I can say. That too mechanical. So I have very little touch of this system, but I know the potential of this area of artificial intelligence, because it's touching each and every facet of it, right from the kitchen, toilet, bedroom, and workplace, and everywhere, everywhere. AI has its role to play, even agriculture and everywhere. And therefore, I feel not only engineers, not only teachers, each one, each one in this country must be aware of this. Not only aware, but they should know something of this. Something of it. I don't expect that each one should be expert into this. But this is something it is going to revolutionize the entire. Things are changing at a very faster pace. Months back, I got an opportunity to interact with one of the eminent scientists, alumni of IIT Mumbai, Professor Dr. Bundele. And while interacting, he said the things that have not come in last 500 years have come in these 50 years. The research and innovations that have not taken place in last 50 years have taken place in these 5 years. And the new things that have not come last 5 years have come in these 5 years. That's the pace. That's the pace. So, but there is a threat that whatever we are teaching to the student in the classroom may get obsoleted by the time student goes out of the classroom. So that with that pace, because technology is changing, industry is changing. Industry has to change. If industry does not change, such industries are being thrown out of the market. We have classical examples of Kodak, Nokia, BlackBerry, many, many, many. So when you're not keeping yourself in that tune, you are out of the market. So as industry is changing, expectation of the industry of the human capital are changing. And we are one who shape the manpower. We convert population into the manpower, you can say, human power. And therefore it becomes our responsibility to shape this man, convert these people, this population, into the human resource. Otherwise, it will be a burden. In 1992, 91, I think when the globalization process started in India, Tankel that GATT was in this thing. Everybody, many people said that Indian economy will collapse if we enter it. But we have proved that yes, we did well. We did well. That is only because of our manpower. So now we are the youngest nation in the world. The demographic experts say that we are the youngest nation in the world. The average population of almost 54% of the average age of almost 54% of the population is 25 years. If we can utilize this manpower to build a nation, definitely we don't have to wait for the decades to emerge as the strongest economy in the world. But it's a challenge. If we can't utilize this, I think we'll have this social problem of unbelievableness. Therefore, the responsibility of education institutions, of the teachers, is the challenges has become a formidable challenge for us. As technology is changing, expectation of the industry is changing, students are also changing. Student expectations from the teachers are altogether different now. When I studied, the expectation and the aspiration of the students in that generation was just get a job in a good company, Indian company, some Bell, some BEML, some Telco, some Kirloskar, some Bajaj. They were the good top companies at that time. Down the line, after 10 years, aspirations of the students changed. And aspiration of that generation was go abroad. Settle there. Again, after 10 years, it changed. It was more confined, more focused. Not just to go abroad. Go to some specific country like Germany and US. Work for a specific company like Apple, Google, Amazon, Microsoft. Last generation, again it was changed. And it was go there, work for a good company and lead those companies. Satya Nadella, Sundar Pichai, Jay Vijayan, Krishnan of IBM, now the Agrawal of Twitter. Day before yesterday, I was reading a local newspaper here in my place at Kolhapur. A girl from Kolhapur, 34-year girl from Kolhapur. She has become a CEO of one of the world's leading garment manufacturing company in France. So this was the aspiration of the last generation, but aspiration of this generation is different. This generation said they don't believe in going abroad and working there. They want to create it here only. And therefore, they do not expect you to preach them. They do not expect you to deliver the contents. They are not at all interested in the contents because they know that contents are available at the click of mouse. Unless you experiment, unless you orient them to convert that information into the knowledge. Because knowledge is different, information is different. What we deliver into the class it's information. What they read in the book is information. If they think upon that, that information will get converted to the knowledge. And if that knowledge is used to solve a real life problem, it becomes a technology. So unless the knowledge, information is converted to the knowledge and knowledge into the technology, not because conversion of the information into the knowledge is a research and it needs money. So research converts money into the knowledge. And second part, technology converts that knowledge into the money. And unless this cycle is complete, the technical education system anywhere in the world will never be sustainable. Will never be sustainable. In 1928, we got a Nobel Prize. Sir C.V. Raman got it for the light effects. What happened to that research? Could we develop a technology based on that? No. Unfortunately, no. US developed Raman scanner and earned billions of dollars on that. So they converted that knowledge into the money. About wireless communication we are talking about. Sir J.C. Bose for the first time in the history of the world talked about it. But credit goes to Marconi. Technology converted by them. They converted that knowledge into the money. So this cycle is to be completed, and to complete this cycle, this culture is to be developed. Unfortunately, it is not being developed. We are emerging as a centers. We are shifting our focus from knowledge-based education system to information-based education system. So unless we create a knowledge, unless we emerge as a knowledge-creating hub, I think we just cannot think of transformation. See, technology and research is always not rocket science. We have to encourage the students to make use of their knowledge, to solve the problems of the people who are at the bottom of economic pyramid of the world. 85% of the population is at the bottom of the economic pyramid. Their earning is just $2 a day, less than $2 a day. 400 crore population's earning is this, and they have access to 9% of the total world's wealth, and 15% people, they have access to the rest of the wealth. When we got independence, the percentage of the population at the bottom of the economic pyramid was 65%. Now it has increased to 85%. Poor is becoming more poor. Rich has become more richer. And technology is a tool. Nelson Mandela once has said that it's a strong tool, have the potential to transform the world. And unless the technology is used, we make use of technology to solve their problems. Make technology accessible to them. See, Nokia, a simple example of Nokia. what they did, the cost of the mobile phone, they made it so affordable. Today, India is having, in India, 98 crore mobile handsets. If all Apple, all Samsung, all iPhones would have been launched into the market, what percentage of the population would have access to that? And when we are talking about the online education, accessibility, and data and all and everything, I think these companies and even Bharti Airtel and Reliance also to a certain extent, the data in India, we are the cheapest data providers. Dr. Raghunath Mashilkar, Padma Vibhushan, the eminent scientist, he says that after three physiological needs, food, shelter, and clothing, data is going to be a fourth need, and it is going to we have to accept that it will become a right. Data will become a right. Yeah, that is the place of a data today, and I think these are the technologies now coming up, which needs a data. So upskilling and upgrading the teacher, making them aware of all these things, making them conversant is not just sufficient. Because this is just taking them to a set benchmark. Benchmark has been set and we are taking them to that level. No, we have to rethink about it. If at all we want to reinvent India, we have to set our data. So we have to set our benchmarks. And teacher has to come out of it. Come out of the traditional things. Because when we think of changing the student, changing the generation, we have to change first. So this change will percolate into the student. I hope this institution, this program, will definitely make learners will have a lot many takeaways from this program. I wish them all a happy learning week, and once again congratulate this institution for coming with this novel topic. And I was listening to the list of resource persons. Definitely, yes, I'm sure you will do it in a fantastic way. And the words of the scrutiny committee you will definitely prove that Poornima is one of the institution has a capacity to do things in the best possible manner. So I assure the complete cooperation of IST in all such endeavors. And once again, thank AICTE for joining with hands with IST for conducting such programs and providing an opportunity to the teachers to upskill. Jai Hind.
Thank you, sir. Thank you, sir, for motivating us. It was illuminating in true sense. Now it's time to conclude the inaugural session. So I would like to invite Dr. Garima Mathur, ma'am, Head and Professor, Department of Electronics and Communication Engineering, for vote of thanks.
Thank you. Now it's time to conclude this inaugural session. I took this opportunity to propose a vote of thanks. It's my privilege to have been asked to propose a vote of thanks on this occasion of online AICTE IST sponsored induction program on artificial intelligence in cooperative Noma 5G network from 21st to 27th December. I, Dr. Garima Mathur, on behalf of the Department of Electronics and Communication Engineering and the entire fraternity of the Poornima College of Engineering, first of all, extend my humble gratitude to Almighty God for making today's occasion. On my own behalf, I extend a very heartfelt thanks to our chief guest, Dr. Pratapsinh Kakaso Desai, President, IST New Delhi. Guest of honor, Professor R.T. Yadav sir, Professor-HAG, MNIT Jaipur, who spared time from their busy schedule to enlighten us on the advances taking place in research and innovation on emerging technologies. I also would like to thank the more than 100 registered participants who have given an overwhelming response to this refresher program. I also express my sincere thanks to Director Poornima Foundation, Architect Rahul Singhi. His able guidance has always encouraged us. Thank you, sir. I thank our well-wisher Director, Dr. Mahesh Bundele, sir, for his kind support vision and commitment. I thank Vice Principal Mr. Pankaj Dheemla sir for their support for this event. My heartfelt thanks to the administrative staff, especially our registrar Somanshi ji, Shivraj ji and Ritesh ji for making everything available to us. I cannot thank everyone enough for their involvement and their willingness to take on the completion of tasks. Once again, I want to state that we are all most grateful to you all. We thank you for being with us and supporting us throughout. It has been a great pleasure. Thank you. Thank you very much. Over to you, ma'am.
Thank you, ma'am. And now I request to all dignitaries and participants to turn on their cameras for a group photograph. Kindly turn on your cameras. I request to all participants and dignitaries.
Thank you, sir.
Thank you.
Thank you, everyone. Thank you, sir. Thank you, everyone. Now we are looking forward to a successful refresher program over the next 6 days, and I strongly encourage you all to become actively engaged in the various course sessions. E-certificates will be provided after successful completion of the program. Participant must have 80% of attendance for the sessions and at least 60% score in the online assessment. Assessment will be done on daily basis as well as at the end. Now moving towards our first session, I would like to introduce our eminent speaker, Dr. R.P. Yadav, Professor-HAG MNIT Jaipur. He has done his PhD in Communication Engineering from MREC Jaipur and MTech in Integrated ECN Circuits from Indian Institute of Technology, Delhi. More than 15 PhD students have completed their PhD under his supervision. He has supervised more than 30 MTech dissertation work in the department. He has completed 2 sponsored research projects of MHRD in the department. He was instrumental in starting new BTech, MTech courses and formulating the PhD ordinance for starting research work in Rajasthan Technical University, Kota, and other affiliated engineering colleges as a Vice Chancellor of the RTU Kota. He had worked as a head of department in Electronics Communication Engineering, President Sports, Library Dean Student Affairs in MNIT. He is currently working as a Chief Vigilance Officer of MNIT since 2015. He was part of various committees of MNIT, various universities, state government, and national formed to address various academics, collaborative research, and policies of technical education. His research interests are error control codes and MIMO OFDM, RF and antenna systems, mobile and wireless communication systems, optical switching and materials, mobile ad hoc and sensor networks, device characterization and MEMS, and cognitive radio networks. I welcome you, sir. Now I would like to invite Dr. R.P. Yadav, sir, to deliver his talk on 5G technologies and cooperative relay in NOMA system.
Yeah, thank you. Thank you, Dr. Anila, for your gracious introduction. To all the participants, now let me share my screen. I think if it is visible, please let me know. First of all, I'll speak about, is it visible to all of participants? Is my screen visible?
No, sir. It's not visible.
No, sir. No, sir. It's not visible.
Just a minute. Not visible still? Huh?
No, sir, it is not visible.
Oh, there is some problem, I think. Just a minute. Just a minute. I don't know why it's... It's visible now?
Yes,
Hello?
sir. Yes, sir,
Yeah,
it
it's
is now
visible.
visible.
Huh? This is visible or not? Huh?
Yes, sir.
Visible, na? I can...
Yes,
Yes,
sir,
sir,
it is.
visible.
Okay, I can start with, okay. Okay, good morning to participants. Little bit hiccups because I am taking from my, joining this particular Google Meet also from house. Such a cold morning in Jaipur. I hope all of you are comfortable, all participants. As in the very beginning, our, you can say, chief called chief guest, Dr. Bundele and Dr. Garima and Dr. Anila, they've already spelled out, you can say, the different aspect of this particular faculty development program. And I intend to talk about this particular new technology, NOMA, and see it in cooperative sensing, or you can say across how this can be used more meaningfully in comparison to the existing technology. So participants, I think, are fairly probably they are already teaching, you can say, in different engineering colleges. So they already understand that what are the little bit of at least basic issues in the technology nowadays. Now, all of you are aware, I think, that wireless communication systems are almost indispensable in modern life. As we can see, their number and variety of devices, that are increasing, you can say, every day on the same, you can say, spectrum. Spectrum, you can say, is same, and devices are increasing, you can say, number of subscribers are increasing. So obviously, the kind of services that can be, you can say, provided to the users, they are coming under tremendous, you can say, pressure, or perhaps, we have to search out for, you can say, additional, technology issues, like internet of things are coming up. That's again, you can say, introducing necessity to connect our every, you can say, subscriber to every object. Machine to machine communication, or you can say person to person communication, massive, all, you can say, connectivity are being redefined now. Now, what is the problem? Let's say why we should know about NOMA. So the current systems have, certain limitations to meet the requirements. Like, you might, as a communication person, you should understand that what is our aim. We want to have, you can say, what is the, you can say, necessities of any communication link, you can say. We want a high spectral efficiency. What is the meaning of spectral efficiency? Spectral efficiency means essentially, in very simple terms, we can define it as, number of bits we are transmitting per hertz. So in the current, you can say, systems, this spectral efficiency is low. Now, very low latency also. That means the response time, you can say, to our, existing system, that is very low. At least not to some real applications, it's a little bit wanting. Then another issues that are coming up to the existing technology are massive device connectivity. You might say, how many massive? Massive means near about 1 million devices per square kilometer. That's what, we are talking about in coming future. 1 million devices per square kilometer. So that's a level of connectivity, you can understand, we are going to work on, or we will have to work on in the coming, you can say, decade. Very high achievable data rate. Data rates are requirement of everybody now. Everybody keeps on complaining that I should have a very good, data rate. Ultra high reliability. Reliability is another issue. And to my all participants, that let them understand reliability in wireless communication is very very different or very very challenging also, because in wired networks, like you can say coaxial cables or optical fibers, you can have a very very reliable communication. In a sense, you can in the existing, you can say infrastructure, once you put it into this particular, you can say, operation, they operate very reliably. But not in wireless communication. Like wireless communication, the channel conditions change very very, you can say, rapidly. And then somewhere you have the hills, somewhere you have the buildings, somewhere you have the trees, and somewhere you have, you can say, all sorts of obstacles. And on top of that, what is this ultra high reliability becomes challenging is because we need accuracy of very high order, because nowadays you can say mobile internet, mobile banking, everything has become online. So this reliability is very important. And this has to be also thought about in consideration with, you can say, our power backups. Because what we want is, the looking to this environment conditions now, global warming, or we want to have at least minimum power consumption. That means the signal that we are transmitting should operate at a very very low level. Now at low level, and with the losses and with other distortions, or you can say interferences, uh, again it becomes much much challenging, I can say. So the persons, at least a lot of young you can say faculty members or researchers, they can think about these kind of challenges, and they can work on some, you can say, solutions for their research, or other BTech or MTech projects also. Now we need high throughput also, supporting diverse quality of services also. Quality of service, I think each one of you understand that, I mean, some benchmarks are defined by TRAI, our Telecom Regulatory Authority of India. So quality of service has to be defined before, services become operational to the satisfaction of the subscribers. Energy reliability, you can say, corresponding to rather efficiency, rather reliability, energy efficiency, and dramatic reduction in the cost also. I think as a developing country like ours, and we have seen like in this mobile communication revolution also, as Dr. Pratap was talking about, when mobile first came into our country, like in a, you can say, mid 90s probably. I mean, those of you who are at least a little bit older, you can say, they can uh, recall that. And so the cost of the call was 8 rupees per minute, or I think 32 rupees per minute in the beginning. That means people were hardly talking. They were probably just trying to give somebody, you can say, and then they will go on a, you can say, landline telephone, perhaps to talk for longer duration. And so this become, you can say, now a reality in a sense, because now every hand has a mobile, from school boys to, you can say, I mean, businessman to household wives. I mean, everyone, you can say. Now this region is simply the volume, sheer volume, or you can say dramatic reduction in the cost. And again, I should not re-emphasize it, but that's a true also, because in such a corona pandemic time, this particular kind of mobile internet, or our, you can say, networking internet across the world, that has saved you can say almost humanity from many kind of, you can say, troubles we could have faced, a student could have faced. I mean, their education, their all other health or other services. And these things are opening up, you can see, new domain nowadays. People are talking about, you can say, you name, health services, you name, you can say, kind of, education, you name banking, you can say, services, or any other, machine to machine communication, driverless, trains, driverless motor, you can say, cars. uh, I think you can say, you name anything, and probably these things are becoming, you can say, reality. And that is where I think we need to understand that technology doesn't, I mean, those who develop technology, like they always have edge over the others. So we know about this 5G or other controversies also. I don't know how many of you are aware about it, but every country, every multinational company, or you can say individual countries also, they look for their national interest and the interest of the, their own general public. So these are, this is the importance, you can say, why we are, at least talking about NOMA, or perhaps, in 5G systems, or along with artificial intelligence. Now, what are some of the suggested, technology that people are now talking as a potential, you can say, candidate? Now we have a millimeter wave like technology. What is millimeter wave? Millimeter wave technology, you can say 30 gigahertz to, you can say, near about 300 gigahertz of, you can say, signals. Now, this is again a challenging area, because first of all, 30 gigahertz, how do you, generate 30 gigahertz signal? As a faculty member, if you raise this question to student, they design an amplifier at, you can say, in kilohertz. If you ask them how this kind of, signal generated 30 gigahertz, how it generates, very stable, you can say, frequency. So as a hardware engineer also, or as a, particular technologist, you have to really, work on these kind of, you can say, solutions. Then MIMO is a new technology, multiple input, multiple output, more small cells. So what should be done, in this particular concept? You can say we have to think about, you can say, some more innovative solutions. And what is a more innovative solution? If you talk about, I think I can skip this, is probably transparency, multiple access. Everybody understands what is the meaning of multiple access. Multiple access essentially means something, you can say, you define the, you can say, rights. Like suppose we join the traffic. Now at, you can say, our street corner, if somebody defines the only 4 cars will be, allowed in this particular time, so the only 4 will enter, you can say, the main road, let us say. So similarly, in a communication also, multiple access means essentially, I mean, how many users can share or can have access to that particular spectrum. So this spectrum is obviously limited. I think everyone understands that, and sharing is necessary to improve the overall capacity over a geographic area. You might see it also, like, in 1960, when satellite communication started, what multiple access we had. I think the technology then was, I mean, you can say, is frequency division multiple access. That means the satellite at a particular frequency, we are transmitting signals, and through the transponders, we are getting back, you can say, our signal back through our television or other services, or you can say weather forecasting, all kind of, you can say, signals we were making use of. Then you can say, you can TDMA that came with the 2G solutions, you can say, and your PCM also. And TDMA is an example of time division multiple access. And in the third generation came what is called CDMA, and that's again important, you can say, particular CDMA solutions, uh, came with the 3G. And that's very interesting. I think probably faculty members who are doing it, I mean, somebody may, understand it, how spread spectrum technology started. Spread spectrum technology had its, like all other technology, spread spectrum also has its roots in somewhere, you can say, security, defense. I mean, defense is a, you can say, mother of probably all technologies. If you look at, most of the, technology. So this spread spectrum technology came because, every country or they wanted a secure communication for their, own, you can say, defense forces. And this CDMA, in fact, which was promoted by, I think all of you know about Qualcomm, which is still a big, company, and the government of India is working some, futuristic, you can say, collaborative, uh, industrial projects also with them. But that technology, allowed, you can say, higher data rates. Now, the question you may pose to yourself or to the student is, where is the problem in TDMA? Why TDMA cannot support high speed? How come, I mean, we have to, change over to CDMA? I mean, this is 2G is almost obsolete now, you can say, as far as mobile services are concerned. So like, now after CDMA, there were still problem with, you can say, mobile internet speed. So 4G came, and what 4G uses, orthogonal frequency division multiple access. That means multiple carriers, they were used for, you can say, to reduce the interference and to give a better, high speed, you can say, download or upload, you can say, upload speed to the subscriber. Please ask any question if you want to. You can interrupt me and you can ask questions also. Hello, participants. Okay, please, you can interrupt me in between also, and we will at the end of presentation also, we will have some, 5-10 minutes of discussion also. So those of you at least who are listening, I think you can interrupt me also if somebody has to ask any question. And then the 5G, where we are talking about non-orthogonal multiple access. That's a technology which is still to, you can say, mature, but being talked a lot about right now, and perhaps that the technology can give, you can say, shape to what we are looking for, futuristic, you can say. So this is a frequency division multiple access, where if you plot, power along with frequency, so each user will have a definite frequency. I think you have already probably worked on these kind of, things. Now, what are the advantage and disadvantage? Advantage is lowers the inter-symbol interference. Equalization is not required because there are already, you can see, a lot of bandwidth we are using. Simple to implement because we have a, active filters, and we can simply have their safeguards, you can say. Fairly efficient with the little base population. But what are the disadvantages? It is suitable only for analog signals. Storage enhancement of signal is not possible. Large bandwidth requirement for transponders. Guard bands may waste obviously capacity. It requires RF radio frequency filters to meet stringent adjacent channel rejection specifications. This may increase the cost of the system. Network planning is cumbersome and time, critical. You can say frequency planning is time consuming again, because how many services you can accommodate, required multi-channel receivers that are very expensive. Now these are some of the, I think, probably disadvantage in multiple. Similarly, for time division multiple access, if you look at, that's a channel access method for shared spectrum networks that came with, you can say, PCM and all, digital technologies. It allows several users to share the same frequency channel by dividing the signal into different time slots. So if you plot time and frequency, then at different time slots, you can, your one of the user can make use of it. The users transmit in rapid succession, one after the other, each using its own time slot. This allows multiple stations to share the same transmission. I think all of you are familiar with T1, and T2 carrier systems that are being, defined through this time division multiple access. Now there are certain advantages and disadvantages. It can convey 64 kbps to 120 mbps of information rates. That's some of the advantage. Offers a solitary transport, recurrence with different clients. No need to have exact narrowband, channels. Isolates client as per the time guaranteed. There is no obstruction from the concurrent transmission, and offer significant investment funds. You can say in base station hardware, space, and support. What are the disadvantages? It is exposed to multipath twisting. Obviously, I think if you, those who are familiar with wireless, communication, they can at least understand it. It's exposed to multipath. You can say problem interference. Organization and range arranging is concentrated. That's again a problem. The biggest problem is high synchronization at a high speed. This becomes a really difficult job to reduce inter-symbol interference or other kind of, you can say, error, you can say, in the transmission. Recurrence opening assignment is to be intricate in TDMA, and signal processing, again a requirement which burdens. This is a code division multiple access where frequency and time both, I mean, we make use of. So each user is assigned a particular code, and that particular code, you can say, at the receiver end, that particular code enables the subscriber to, you can say, recover the information transmitted. And so number of, I mean, many of you might be perhaps knowing it also, and that how many subscriber, how many, kind of services can be supported by CDMA. Theoretically, if you look at, these orthogonal codes like Waltz code that we use mostly in this kind of systems, that give 64 bits, you can say. So in theoretically, you can have enormous number of, subscribers which can be serviced by the CDMA, you can say, system. But uh, the question again is interference, because this interference is a big problem in CDMA, multi-access interference, which is called MAI. Okay, and the first system that came is IS95, CDMA1, 3G evolution, CDMA 2000, and this is nowadays UMTS, you can say. A lot of names are, you can say, being put into across Europe and US. All the different kind of nomenclatures are used now. More widely used are wideband CDMAs, or TD CDMAs, and you can say TD SCDMAs. I think you should appreciate that technology there is no, it's a technology improves, or you can say from one you can say pedestal to the next pedestal, depending upon the, you can say, requirements. And so a lot of engineers or scientists, they try to solve that problem by coming up to solutions. And that is why these so many different versions of even CDMA has come. Now that's again, if you look at code division multiple access, it doesn't need any synchronization. It has better multipath execution, and it has multiple times limits, uh, you can say better than GSM in many capacity or other advantages. Now, what are disadvantages? Time synchronization, of course, depending upon the speed that your data that you are transmitting, that's required. It cannot offer international roaming, a large GSM advantage. The CDMA system performance degrades with increase in number of users, as I said, and signal to interference ratio, that becomes a problematic. And while we are using CDMA, code length can be carefully selected because it can induce delays. And there are self-jamming problems also, which inflict, you can say, or this particular system is infected with. Next one is OFDM. In OFDM, I think you, as you have already probably know about it, that in OFDM multiple closely spaced orthogonal subcarriers are transmitted with overlapping spectra, and the data is carried in parallel. So demodulation is based on fast Fourier transform algorithms. If you look in this diagram, corresponding to different carriers. Now, some of you might be having, this particular, you can say, curiosity also, that why we are using multiple carriers here. What was the need to, rather than single carrier, let's say multi-carrier. So in wireless communications, I mean, the biggest advantage of FDM you can name is, the kind of channel fading you are familiar with, maybe flat fading, or maybe you can say frequency selective fading. So the advantage of, using OFDM is you can say frequency selective fading, it gets translated to flat fading, where you can easily, you can say, plan out, you can say, your power requirements. If it's a frequency selective fading, then it's a really big problem. So that's was one of the biggest advantage you can see for OFDM. And of course, it helped into reducing the interference and increasing the speed also. Okay. And so what are the advantage of OFDM? Efficient use of a spectrum by allowing overlap, that you can see, eliminates ISI and IFI through use of a cyclic prefix, that we can add up. You are, I think, familiar with these terms. Simple channel equalizations. Channel equalization is again a big problem. I think delays are always a part of any wireless transmission. OFDM is computationally efficient by using FFT technique to implement. Now, since this FFT has become now a possibility, so that is why you can say OFDM become also a possibility. So many technologies are interlinked with our hardware. You can say availability of the corresponding hardware to implement also. Modulation and demodulation functions provides good protection against co-channel interference and impulsive parasitic noise. Now, what are disadvantages? RF power amplifiers with a high peak to average power ratio are required. Understand? High peak to average power ratio, that becomes a problem, because whether the amplifier operation linear or non-linear region, so maybe some, you can say, other issues related with this particular high peak power ratio. It's more sensitive to carrier frequency offset. Because if there are, this carrier frequency offset means, that's what I said about oscillators, because oscillators may not be, you can say, producing stable, and if there are some you can say, path propagation, the phase might be changing, and if the frequency is changing, you can say, at the carrier itself or at the generator itself, then that particular transceiver noise may get also added up to this kind of systems. Now comes the non-orthogonal multiple access. Now, orthogonal multiple access techniques, I mean, only one user can be served in each time frequencies block, you can say. Traditional orthogonal multiple access. Now, this drawback limits the applicability of these access techniques in 5G and beyond era, because as I just named, I mean, spectral efficiency or device, density that is coming up, which requires massive connectivity, high spectrum energy efficiency, large throughput. I think these are some of the requirements, perhaps, this particular orthogonal cannot put on. And so we thought about, I mean, scientists or engineers, what, I mean, the kind of, other system which can fulfill all these requirements. So as an alternative, non-orthogonal multiple access has become a promising solution to overcome the limitation of this orthogonal multiple access, since they provide additional degree of freedom from non-orthogonal source utilization in either the spectrum domain, power domain, or core domain. Understand? Utilization, I'll explain that also in my next slide. These domains extend the dimensionality of these particular RBs so that multiple users can be served in the same RB. Okay, I mean, you can see the corresponding resource block, I mean, that we are using in our wireless communication. Now, non-orthogonal multiple access, if you look at channel capacity comparison of OMA and NOMA in an AWGN channel, okay, additive white Gaussian. So you can see here, I mean, if you look at, you can say orthogonal and non-orthogonal, channel capacity. I think all of you are, you know about, I mean, channel capacity theorem, how much information you can, deliver. So NOMA definitely is much better than you can say corresponding to orthogonal, and that's what one of the requirement now, you can say, in our current modern times. Everyone is talking about, you can say, high speed. No, I mean, perhaps from SMS, you can say some simple carrier, some very limited, you can say, characters we were able to transmit in the very beginning of, you can say, mobile communication. Now everything, you can say, our this OTD or these platforms, you can see the movies, in fact, in the kind of mobile speeds now we have. So I think it's depending upon the application this is coming up. Now, what are the types of non-orthogonal multiple access? They can be classified into two categories: power domain multiplexing and core domain multiplexing. What does it mean by, you can say, power domain? Let me explain it. I mean, this is, what is meaning of, you can say, power multiplexing is, in case of NOMA, I mean, we can transmit the particular, you can say, signal at different power levels. Okay, increased demand in mobile communication now. You can say user 1 and user 2. If you look in the Ofdm, they are having a, you can say, spectrum now. In case of, if you look at NOMA, I mean, I'm transmitting, you can say, one user at a one power level, another user at a different power level. So you might say that how this is possible. This is possible because at the receiver end, we will have, you can say, a system, what is called, this successive interference cancellation system, which, you can say, picks up the, largest one, and then depending upon, will keep on, you can say, decoding until it gets, its own, you can say, signal back. So of course, computational power, it does increase at the, subscriber or this user handheld devices. But now looking to the kind of, mobile handsets we have, you can say the kind of computation power, already, you can say, available with this kind of systems, it is possible that these systems become a reality. Okay, so what is meaning of, NOMA based on, you can say, power multiplexing? So if you look at, power multiplexing in NOMA, you have user N, user M. I mean, you can say corresponding to across power and frequency. Now, if this is your base station, from the base station, what you transmit, you can say superimpose signal of for the user M to N. I mean, depending upon whatever the number of users which are linked with the base station. So what user M, you can say user M detection. Let us say it first detects the user M and then subtracts that user M's, you can say, signal from the you can say corresponding transmitted signal, and then user N detection. I think most of you must be familiar with, this kind of successive interference cancellation. Those at least who have a background in, spread spectrum signal, or at least must have studied in BTech or MTech programs, that the successive interference cancellation, because in case of, for one subscriber, the other signal acts as a interference. And so based upon, this successive interference cancellation, I can recover back my, signal, desired signal back. So now user M may be detected in one step, but I mean, maybe user N will be detected after, you can say, user M is detected. So that is a downlink NOMA, transmission. Understand? Downlink and uplink. Obviously, in uplink also, which will be okay. Now, if you look at, uplink NOMA technique, user M and user N, they uplink with the base station. Okay. So if you look at, this particular base station, user M and user N, Now, user and detection and user M, this particular successive interference cancellation, and then user M detection. So both kind of, uplink and downlink, you can see that how this particular power multiplexing takes place. Now, this is an example of, you can call it non-cooperative, you can say NOMA, and this is called cooperative NOMA. Okay, understand? If you look at cooperative NOMA, that's in the first case, you can and NOMA, that is a case of, you can say, uplink. Now, on power multiplexing and downlink NOMA transmission, if you look at superposition, coding, that at the transmitter that we are now talking about, you can say both kind of, you can say power and code based, and successive interference cancellation at the receiver. So superimposed signal, again the same thing, you can see this is, we have already talked about this particular transparency. Now, this is NOMA based on power multiplexing, uplink NOMA transmission. That's again probably more thoroughly explained. Multiple users transmit their own uplink signal to the base station in the same, resource, you can say, link, and then this base station detects all the messages of the users with the aid of SIC. Understand? Again, you can say this successive interference cancellation will work at the, you can say, base station also. The basic form of NOMA with SIC exploit SINR difference among users either due to natural near-far effect or by non-uniform power allocation at the transmission. Now look at, this particular, I think all of you are familiar with near-far, effects in direct CDMA systems, that perhaps you are familiar, and that can be non-uniform, power allocation to the trans, because one subscriber may be away, another one may be, you can say nearby. Okay, so if you look at in this base station, what we do is user and detection. This is a serious, you can say successive interference cancellation, and the base station picks up, you can say, the corresponding this uplink signals, and then processes them for the further transmission. NOMA based on power multiplexing, if you look at, NOMA in massive MIMO systems. Now, again, I think you should understand that the kind of system that we are looking up now, and what you can call as a spatial multiplexing, it's independent of one, you can say, time, frequency, and even space also. Like the same frequency can be used by number of, you can say, subscribers. If those particular, you can say, separate beams are provided to the subscriber. Understand? So, the time, you can say time, frequency, and even space also. Okay, so this kind of, NOMA based, power multiplexing, that's a distinct possibility. I think you understand what is meaning of a spatial multiplexing means. You can generate a particular, this kind of waveform through your antenna, and that the same signal, same frequency signal can be used by we can say two users or maybe more than two users in the you can say different planes or different, directions. Now, NOMA in massive MIMO systems. Massive MIMO system, I think a little bit. All 5G solutions are coming to perhaps reality with only massive MIMO systems. Now, this can be used in conjunction with the multi-user, multi-input output, to further improve the system spectrum efficiency. I think all of you are familiar also a little bit with MIMO also. You can have multiple transmitters and multiple, you can say, receivers to increase the capacity. Multiple transmit antennas at the base station are used to form different beams in the spatial domain. Look at here, as I said earlier on, this transmit antenna at the base station are used to form different beams in a spatial domain, in space coordinates, where each beam adopts a basic NOMA. Okay, so that means a single beam can have a lot of signals which can be taken care of at the receiver. The interbeam interference can be suppressed by spatial filtering. Okay, so spatial filtering can be done to suppress that. Intra-beam SIC can be used to remove the inter-user interference. Again, I think this is straightforward. The extension of NOMA in massive MIMO system can further improve spectral efficiency. I think this is going to be the futuristic technology. As I'm talking about the massive MIMO systems, this kind of power sharing, this kind of spatial multiplexing, you might say that what is right now, or what is the what we will have to do to make it the reality. but this is easier said than done, because if you look at a particular subscriber who is moving, how do you move that beam along with, you can say, the subscriber which is linked with that particular, or provide him in the corresponding link. So again, you can see the backend processing, you can see signal processing that is required based upon the inputs, getting feedback signals, and this particular beam formation, that is obviously, again, you can see, going to be challenging. Now this is a NOMA based on power multiplexing. You can see user 1 and user 2, I mean each pair base stations we can, and corresponding to the sale also, I mean NOMA, I mean use pair, we can make use of it. Now, network NOMA, when transmit power allocation is biased towards faraway users in downlink NOMA cell edge, users experience increased interference from neighboring cells. Obviously, I mean, you can see the subscriber which are cell edge, they will have problem. In two-user NOMA scheme, it is assumed user 1 and user 2 are served by base station 1, while user 3 and 4 are served by base station 2. The strong interference is expected between user 1 and 3, which may degrade the performance of, that is, multi-cell NOMA. You can see the diagram. Okay, a diagram maybe not, I mean, this is not no diagram, but I mean, in the upper one, you can say beam formation. Let me show you that. Yeah, this one. Like if suppose user 1 and user 2 are getting served by one beam, and user 3 and user 4 at the cell is, I mean, this user 1 and 3 may have, you can say, interference issues. Now, network NOMA that we have already talked. Now, to mitigate the inter-cell interference, okay, inter-cell interference means within a cell, joint precoding of NOMA user signals across neighborhood cells are considered. Understand? Precoding on NOMA users. I mean, the users can be identified with certain available at the fact that large scale feeding would be quite different between the links to different cells. The complexity reduced precoding scheme for network NOMA has been proposed, in where the multi-cell joint precoder is applied only to cell edge users. So rather than putting it to, I mean, across the edges, this precoding, I think precoding everyone understands. I mean, you can say add up certain, you can say code. Now this is here, code domain multiplexing, how this is done. Now this is one example. You can say low density spreading CDMA. Now, in case of low density, this is spreading, orthogonal frequency division multiplexing can be considered as a combined version of LDS, CDMA, and OFDM. In LDS OFDM, the transmitted symbols are first mapped to certain LDS sequences and then transmitted on different OFDM subcarriers. So what is the user one? I encode this information, I map it to, you can say, corresponding to a carrier, and then I transmit it. Okay. Now, the number of symbols can be greater than the number of subcarriers. That is, the overloading is allowed to improve spectral efficiency. This is one of the, you can say, uh, technique, perhaps, I mean, not, you can say, exclusive technique, but one of the technique which can be useful in case of, you can say, precoding. Now, NOMA based on code division, code domain multiplexing. What does it mean? It means essentially, and one of the technique is what is called sparse code, multiplexes. What is meaning of sparse code? Now, bit streams are mapped to sparse code words. That means, like, I have the code, you can say code book 1, 2, 3, 4, or whatever the, you can say, corresponding, I mean, number of code books I have, and we have 6 sparse code words are transmitted over 4 orthogonal resources. Okay. So what I do essentially is a particular code will be picked up. You can say corresponding to this one, corresponding to this block, another code to this one, to this one. You can say corresponding. If I make use of and I combine them, this will be my multi-user. You can say, I mean, signal that I'll be working on. Okay. Yes. Any question? If you have any question, please. MUDs. Essentially, that means the code that are getting being used to spread a particular informations are different, and then obviously at the receiving end also I try to you can say decode the same kind of coding information. Enhanced version of LDS CDMA, unlike LDS CDMA, SCMA directly maps different bit streams to different sparse code words. That's again in an improved scheme. Each user has a predefined code book, all code. I think we still have a time. Hello. I think
Yes,
we
sir.
still have some time.
Yes, sir.
Yes, Dr. Anila, I think we
Yes,
have
sir.
time.
Yes,
Okay,
sir.
okay, let me continue for another 5-10 minutes. For each user, 2 bits are mapped to complex code words. Code words for all users are multiplex or 4 shared orthogonal resources. And the key difference between LDS CDMA and CDMA is that multi-dimensional constellation for SCMA is designed to generate code books which bring shaping gain that is not possible for LDS. I think again these are not the only technique. You can see power, multiplexing and code multiplexing. You will have, I mean, those of you at least you can make use of this different codes. You can say multi-user shared access also we can use. Then we can, I mean, sparse code I have already talked about. Then you can low density spreading also. You can have pattern division multiple access also. You can have bit division multiplexing also. In all these are, I mean, you can say the technology techniques that are being explored for implementation of 5G. Different, you can say, environment you can talk about. Now this is what is sparse code. You can say multiplex access. I can explain it more, at least in simplified manner. The shaping gain is higher when the shape of the constellation is closer to a sphere. And the maximum achievable shaping gain by the optimization of a multidimensional constellation is 1.53 dB. You understand? I think constellation, every one of you understand. That's a
Hello, sir.
basically
May I
signal
ask you a
strength.
question, please?
Yes? Any question, please?
Yes, sir. Why this CDMA is known as is utilizing spread spectrum technology? Can you please explain how the spectrum is spread?
How that is spread? I think probably yes. That's a very I think a question perhaps when you come across first, like as a student or as a learner, when somebody says how can a spectrum be expanded? It is not something some sort of rubber you can say you stretch and then it becomes spreaded up. So how do you spread the spectrum? But for that purpose, I think if you understand, a bandwidth of a particular pulse, that is how do we define the bandwidth of a particular signal or pulse? It is inversely proportional to the duration of the pulse. Okay, so that means if I am having a 5 millisecond you can say pulse, then I can calculate, I mean, this particular you can say bandwidth requirement of, you can say, that will be inversely proportional to 1 by, you can say, 5 millisecond. Now what is done is spread spectrum is this 5 millisecond you can say pulse is, you can say, reduced form. I mean, you multiply by a particular PN sequence, the pseudo noise sequence, and so pseudo noise sequence depending upon its length. I mean, this may be as smaller as, you can say, 0.01 millisecond. Suppose now the pulse that you are transmitting is 0.01 millisecond, let us say. So that means 1 upon 0.01 millisecond means what? This particular signal will now occupy more bandwidth. Understand? If my
Yes.
baseband signal had,
Yes, sir.
if my
And sir, one
baseband
more
signal had
thing
5
that I would like to
milliseconds.
ask you is,
Hello?
yeah, one more thing that I would like to ask you is,
Yes.
this NOMA, it falls under channelization kind of random access techniques, right? Because
Yeah,
there are other kind of random access techniques as well, like round robin or aloha, slotted aloha, CSMA CD, CSMA CA, and so on. So this falls under the channelization kind of schemes. So
yeah,
have you explored the
channelization.
other kind of schemes?
Channelization? Yes. I think what you're talking about, Sloha, or you can say these are not normally used in our, network access, But in case of NOMA, our main problem is how do we transmit, you can say, more signal or more, you can say, data rate to our subscribers? What is the best way? Looking to our limited, you can say, spectrum. Okay. So what you are talking about as channelization, or again you are defining some access. In a way, what you are saying is in network, when you define it like slotted aloha, I mean you fix the slots, like you can't randomize, So similarly in NOMA, we are searching out a particular tools where, I mean, my user can make use of more spectrum, or I mean rather than like in FDM, if I have a carrier, you can say corresponding to based on my carrier, I mean each carrier will carry on some information. So that means that spectrum will be exclusively used by that user. In case of NOMA, you can see more than one user can share the spectrum. Understand? So essentially, I'm defining, you can say, my access. I mean, depending upon my, you can say, limited resources, we have to, somehow make use of the spectrum, whatever spectrum is there, to the most efficient way. And in any case, I think
sir,
if you
just
look at
one
5G
thing.
solutions,
Sir,
millimeter
can you just
wave or
explain this NOMA in layman's language? Actually, I did not understand it well. Difference means
NOMA,
what is the new thing about NOMA, the basic fundamental
yeah,
concept?
NOMA, of course, there are many things in NOMA you can say, but one most elementary thing is that you can advantage you can understand is because if you look at in NOMA, I mean the two users are sharing the same spectrum, and each user can make use of the whole of the spectrum, and power levels are also very small. You can see our energy efficiency, all other issues are also can be taken care of. You might say that the same thing goes in CDMA also, like a lot of users can share the same kind of bandwidth, you can say, but their multi-access interference is very high, you can say. And so my essentially signal quality, signal to noise ratio quality at my receiver end will be a problem. Here I can ensure more accuracy in a sense because each particular subscriber will be decoding its information, and I keep on through successive interference cancellation, I keep on decoding that information so that I get my signal back more reliably. Okay, so it's essentially, you can say, I'm increasing my speed. Now the kind of application that we are talking about, video, I mean live, you can say, this particular streaming or this kind of applications, I need more speed, you can say, so that of course we are going to the higher spectrum also, and we are making use of this technology to make available more bandwidth to our subscriber. Okay.
Okay, sir, just
Yes.
one last question. Sorry, I'm asking too many questions during your presentation.
No
Just one
problem.
last question. That is, in case of TDMA, time division multiple access, all users are using the same spectrum, but they are sending it or receiving it in different time slots. So here also you are talking about users having the same spectrum. So why not to use TDMA, which is well-known technique? Why to go for this NOMA?
Yeah, but
If
in
spectrum is same.
TDMA, yeah. And I think you can make out, like in TDMA, a slot particular that you allocate to a particular subscriber that has a very limited capacity. Okay, that's why in PCM we have a constant speed like 64 kbps. It's not flexible. Either use your two slots, you can make it 128. Understand? And that
Yes.
this particular slot synchronization will be a more problematic, you can say. I can't synchronize more than, you can say, 2 or 3 slots, you can say. So in TDMA I cannot increase the speed. There is no flexibility like scaling up or scaling, I mean, like in CDMA we have that scaling, because आपके पास में मान लो 2 सब्सक्राइबर ही हैं, तो 2 सब्सक्राइबर सारा बैंड यूज करेंगे corresponding to. बट यदि मैं टीडीएम में बात कहूँ तो इट्स नॉट पॉसिबल कि मेरे पास 2 सब्सक्राइबर ही मान लो यदि टेलीफोन कर रहे हैं तो सारे उनको यूज करेंगे, ऐसा नहीं हो. Okay, so what we essentially want is, I mean, as I said, the basic, you can say, premise, based upon this 5G solution is, what we are looking for is some real-time applications, like what we're talking about: automation, driverless cars, driverless trains, machine-to-machine communication. You can say very, very reliable and real-time communication with low latency, you can say. So that's a crux of, you can say, the kind of 5G applications. Of course, there are many issues, other issues. We are not covered all issues. You can say, like, if you go to high frequency, that obviously, so, there are many problems. There are many problems, because the moment you go to the high frequency, there will be a lot of losses. So how how many base stations you will have to have, and then base station to be, suppose there is a if a big you can say truck comes into in between the communication, what happens to my communication, because millimeter wave may not can go through. So lot many issues. I think rather we are only you can say having a particular conceptual you can say of course this is getting a reality. NOMA is becoming a reality as a technology, as you can say, we can this realizable, or this is being already pilot projects are being, you can say, tested. So that's an issue, but all other issues are also there. Handovers are there, then you can say corresponding to identifications are also there. But of course, I think many other probably speakers will making talking about, I think, this kind of other issues. Okay, I hope I have you got your answers. If not, I mean, you can mail me also after this. Is the appropriate design criteria and specific solution to multidimensional problem, there are still unknown. A multi-stage approach has been proposed to realize a suboptimal solution. Because look at this particular technologies, what we are talking about, the code division multiplexing. All of you know that coding every student understands now. At least I think when you do your undergraduates, little bit of coding background everybody learns about, block codes, convolution codes, turbo codes, you can say low density LDPC codes. I mean, those particular codes, they have been always useful, you can say. So in an n-dimensional complex constellation means vector space, your symbol space, with M point, which is called the mother constellation, is first optimized to improve the shaping gain. You might say, what is meaning of shaping gain? Because you combine the signals. Understand? When you combine the signals, like all the signals, they travel, let's say, by the base station together. So what should be, the combined, you can say, their envelope gain, shaping gain, and then some codebook specific operations are performed to the mother constellation to generate the n-dimensional constellation. I think coding gain, a lot of you might be probably familiar also, like coding gain, gain along the coding can give you some gain also. That's the meaning here. Three typical, and then optimizing the constellation, picking up the symbols which can give you optimize your gain. Three typical operations are phase rotation, complex conjugate, and dimensional permutation of the constellation. I think this is, again, you have to work at a design engineer level, where I want my this particular, this coding gain to be higher. In the generated n-dimensional constellation after code book specific operation, each n-dimensional constellation point is multiplied with the projection matrix to generate k-dimensional code words, which has n non-zero elements from the components of the n-dimensional constellation point. In this way, code books with M code words can be obtained. I mean, this is one form of, you can say, generating this kind of, you can say, codes which can be utilized for identifying different subscriber and application. Now, this is a, I think it makes more clear. This, I mean, code domain multiplexing, if you look, each user symbol are spread by a specifically designed sequence. Okay. So if user one is there, it will make use of, you can say, one, I mean, each user symbols are spread by specifically designed sequence. So similarly for user one, user two, it can pick up, a particular, sequence for spreading. What is done here is this spread symbols are transmitted on same orthogonal resources. And then I use this SIC, successive interference cancellation, to use my user one, user two, and user three signals, you can say, basically at the receiving end. Now, I think code domain multiplexing, multi-shared access that I talked about. In the uplink, this particular MUSA system symbols of user are spread by spreading sequence, that I think I already talked. And the receiver, this code word level SIC is used again to recover it back. That's again the share link. For the downlink, the operation is more or less the same. And in conclusion, the NOMA eliminates the limitation of conventional orthogonal multiple access technique, where only a single user can be served in each time frequency resource block. It improves the efficiency of the system compared to conventional. I think NOMA allows controllable interference to realize over loading of the cost of tolerable increase of receiver complexity, the demand for spectral efficiency and massive connectivity. It's a very suitable, you can say, candidate for multiplexes. It's expected that NOMA will play an important role in future wireless communications. I want to show, I mean, these are some of the references also, like five disruptive technology directions for 5G, IEEE Communication Magazine, that is 2014. I think this is the first time. Non-orthogonal multiplexes for future radio access. This is the proceedings of IEEE. I mean, these papers, I think this will be available. I want to show something more also, I think, but in any case, I think the time is over. So, Dr. Anila, I think my time is, hello?
Yes, sir. Yes, sir.
Hello? Yes, I
Yes,
think
sir.
my time is probably, I have finished my time or I can continue. Yes, Garima?
Yes, sir.
Huh? Yeah, can I? Huh?
Yes. Sir, you
Yeah,
can.
probably, maybe the artificial intelligence part I didn't perhaps, but I think that's inbuilt in this kind of system.
Yes, sir.
Okay, I finished, Garima. Yeah. Any more suggestions, Garima?
No, sir. Can suggest.
Yeah, I hope, I mean, the participant must have enjoyed it, or perhaps, if any query, you ask them to mail me also. I'll answer their mail.
Sure, sir.
Thank you very much, sir. It was a very
Any
nice
other
session, sir. Thank you, sir. You have
participants? If you have any query, you can unmute yourself.
Yes, good afternoon all.
Yeah, if
This
he
is
see some query, some participant wants to, ask.
yes, yes, sir. Yes, sir. I have one query.
Okay,
Uh,
okay, please.
Sir, this is Rajesh from Nirma University. Sir, actually,
Okay.
my query is there is one scheme that is OFDMA and another is NOMA. But in between, there is one more scheme that is SCFDMA,
Yeah, yeah.
single carrier. So, what is the difference between OFDMA and SDFM? Actually, I'm not getting clear concept of this concept. So,
I
because
think,
OFDMA is also
yeah. I think, you know about FDMA, you have multi-carrier, transmission. So rather than multi-carrier transmission, if you make use of it, that's a single carrier for a single user. Okay.
okay, but but sir, the OFDM is also for one user serve at a time.
Yeah. I mean, OFDM doesn't serve one user at a time. I mean, that's not the point. The point is, each user is allocated certain frequency, and that particular
Okay,
frequency spectrum is divided into number of subcarriers. And each subcarrier is put on
okay,
some, you can say, symbol or some bit information. So rather than
okay,
that,
okay,
you can use a single carrier rather than multi-carrier, because why we are going for multi-carrier is because of frequency selective feeding. Like
okay, sir, done.
some of the frequencies are attenuated more than the others.
Yes, yes, sir. Got it, sir. Got it.
Okay.
Thank you,
Hmm.
sir.
Yes. Any other query? In fact, I wanted to inculcate, or perhaps maybe Garima, mathematics. I could not, this downlink calculations or uplink calculation. I had some slides on mathematical, treatment also
Sir,
with NOMA,
sir.
but somehow, I mean, that particular kind of, maybe this particular participant might have benefited more if I had some mathematical, calculation also. But maybe in some other lecture I'll cover that.
Sure, sir.
okay. Thank you, sir.
Okay.
Thank you so much, sir.
I requested all the participants kindly turn your camera for a group photograph.
For a group.
Thank you. you so much, sir.
Okay, Garima.
Thank you, sir. Thank you, all of you. Now, next session will be at 12:30 p.m. Kindly join 10 minutes before the session. And as we know that 80% attendance is mandatory in the refresher program, and we are taking the attendance through the software. So kindly join the session 10 minutes before. Okay, thank you all.